Let's take a look at the EV3 Classroom app. Whether you're on a Windows device or Chromebook, locate the app icon and select it. From here, we can go to Home or select New Project. For our purposes, we're going to look at Go to Home first, because this is a nice screen to start with. If you forget where things are, up along the top, you can always get back to this screen. There's a Start menu, which gives you great step-by-step instructions on different types of builds and how to program. There's a nice teacher preparation section if you're brand new to EV3. Of course, there are established units you can use with anywhere from 6, 7, 8 lessons per unit that cover different kinds of ways in which the EV3 can be used to support your curriculum. If you're looking just for build instructions, so if you were a school that owned your own EV3s and you're looking to go beyond the basic driving base, there are a number of different build instructions contained here for different ways you can use the EV3 platform to support your program. And these are just the ones hosted inside of EV3 Classroom. Of course, if you go on to the wider internet, you'll find endless numbers of build instructions and different ways that you can engage your students. My projects is just a view of all the coding that you've created within this particular software. So I'm going to close this and we're going to go to New Project just to get a view of what it looks like inside here. If you've ever used any block-based coding platforms, especially Scratch, this is going to be very familiar to you already. This is built on the Scratch platform, and it's just a customized version that works specifically with the EV3 robotics platform from Lego. Along the top, you'll find your projects listed up here. Right now, this is just called Project 3 because I just opened it without any purpose. But if I wanted to rename this, you can just click on the 3 dots here and you can rename your project. I'm just going to call this Demo for now and click Save. And then along the left-hand side, so there's our Home button that will take you back to that screen we looked at previously. And just very similar to the way you would look at different categories of coding blocks in Scratch, along the left-hand side in EV3 Classroom is the same thing. So we start with our motors command blocks. These now, if you were really trying to control one motor at a time, independent of the other motor or motors, this is probably the best category to start with. However, if you're looking at moving your robot, so if you've done a driving base and you want to control the ways in which the robot moves, this makes a lot more sense to go into the movement category because the motors will work together to help you drive more readily. Under display, this is a reference. If I'm going to click here for a second, if you look at this Lego Mindstorms screen here, this is a display. And while the display can be used to access different menus on your EV3 via these tabs that run along the top, the screen can also be used to display parts of your code. So for example, if I wanted to create a facial expression on my EV3, there's some different ways to do that. So the screen, in addition to allowing you to access more information about your EV3 and run programs, it can also be used as an output when you're coding your robot. Under sound, I'm just going to delete that. So by the way, when you want to delete a specific block, you can just click and hold it and drag it back over to the area over here and let go, and it'll automatically delete it. When we are playing sounds, okay, there's different sounds that are already preloaded in here. Let's see if we can zoom out a bit. I'll roll this up. A wide selection of preloaded sounds. And so again, this could be an output that plays when you trigger that output based on something that's going on with your robot. Another way you can use the sounds is to get a kind of onboard keyboard, so to speak. And so if I click on the play beep button, you'll see I can go essentially have access to an onboard piano. Of course, if this is some sort of alarm system you're creating, this might be a good place to go. But also if you're looking to integrate some music into your robotics program, this is another way that students can take information they might already have, such as knowledge of musical notation and keyboards, and create different kinds of sound outputs based on what they're programming on their robot. If we go into events, this is probably going to be one of your most accessed categories of coding block. So we have when the program starts. That's a very common one to use. Depending on your uses and what you're trying to do, you might often want to choose this one when you are starting any piece of code that you're going to use to run your robot, especially for movement. However, there's other available starting blocks as well, right? So we have our light sensor. So that could be when the robot receives a certain type of light information, we're going to have something happen in response to that. Same with our push sensor, which is like an analog button that gets pressed. So you might use something like this, if your robot were running towards a surface or a wall, and you wanted that to trigger a particular action that you've programmed. We have our ultrasonic sensor, which senses for vibrations or sound, and you can call actions to happen after that. And then we also have a gyroscopic sensor that can attach and detect what angle the sensor is sitting at and have different actions happen for that. So that might be really useful if you are trying to detect if your robot is falling or if your robot is on an inclined plane of some kind. And then there's also a number of buttons. If we go back to this screen for a second, you'll notice there are a number of buttons on the face of your brick. And these buttons can be used as a way to trigger events on your robot as well. Um, and there's some other events starting points here as well. I'm not going to go over all of them. And in our controls, this is probably the second most important set of coding blocks available to you. If you've used Scratch at all, you're probably familiar with a bunch of these. So we have our wait block, we have our wait until block. So these are ways of creating time-based pauses when running a program. So if you want a space between a time space between when one event happens and the next event happens, this is a way to do that. We have our repeat block, very handy. In particular, if you're trying to do, repeated actions. So a great example, is if I wanted my robot to drive in a square, well, I could code it in sequence to have it move a certain distance, stop, turn at a particular angle, and then move again at that same distance and stop, and repeat that code in sequence, which is an inefficient way to do something that if I were to use a repeat block, I could take that same code, put it inside here, and repeat it 4 times. And that would be a way of driving a square without having to write as many lines of code. And then this next one, forever, if I were to put that same repeat block inside a forever block, well, now my robot would continuously drive in a square until I stopped my robot. So these are very important blocks. Forever is also really important in a number of different ways. Not only will it continually run a piece of code that you have inside of this block, but it will also continuously check if a condition is true. And so that's really important. We're going to cover that in more detail later. But your forever block is one of the most important blocks. And then the next two, I'd say that are, just as equally important as the others is your if statements. I'm just going to grab another start so we can have both out at the same time. And your if then else statements. And these they work very similarly in a way. Basically, an if statement is saying if a condition is true. So if I go down to my sensors for a second, if the push sensor is pressed, then do this, right? And so we were talking earlier about, display and sound. So maybe if push sensor is pressed, let's do that as a sad face. So, and so in this case, let's say we have our touch sensor in here, and we're going to say if touch sensor is pressed, and this one refers to which port the touch sensor is plugged into. So in this case, it's port 1. So if touch sensor plugged into port 1 is pressed, then display the expression sad. So maybe this would be a way of, let's say your robot was moving autonomously in an open space, and you've got the touch sensor there to detect when your robot is coming into contact with a surface or a wall. Then you're going to display the sad face, and then of course you could have that could also be a command that tells the robot to stop, maybe turn 90 degrees and continue forward. So a way of autonomously solving the problem of what happens when you crash into a wall. And then if we look at if, then, and else statements, it's really exactly the same, except that we're going to return to another condition. So let's take that idea even further. So we're going to go, when program starts, if touch sensor is pressed, we are going to display eyes, and we'll make them sad. Then we'll add a movement command as well. And we're going to say stop moving. And then we're going to go reverse. You could do rotations or degrees or seconds. I'll just do seconds for now to keep it simple. We're going to reverse for 2 seconds. And then we are going to turn 90 degrees for 1 second. And then you could continue moving forward. And again, we could make that, we can make these all seconds if we wanted, just to keep it simple for now. And so what's happening so far? So when program starts, if the touch sensor is pressed, we're going to display the sad face on our display. We're going to stop moving. We're going to move backwards for 2 seconds, turn right for 1 second, and then move forward for 1 second. And then the question is, what would we do with this else statement? And that could be, and so basically that is asking the question, if touch sensor is not pressed, what do we want to have happen there? And that might just be, some sort of continuous movement. Could be for a number of seconds, could just be moving forward. Lots of different ways you can code that. But that just to give you the general idea. And I think one really important thing to just convey here, I know we're just doing a tour of the program, but both of these would really require this forever block to make this continuous. In other words, we want our brick to continuously check if these conditions are true. And if you don't have that forever block, it'll only run the sequence a single time. So it's not going to continue to check if those things are true. Okay, I'm going to move on to sensors. Of course, we have all those sensors we talked about. So there's specific blocks for each of the types of sensors that are available to you. So again, we have the light sensor up top. There's quite a few different blocks for that. We have our touch sensor here, our ultrasonic sensor, checking for vibrations and sounds, our gyroscopic sensor, and of course, we can also use our buttons as inputs as well. So the buttons that are on the front of your brick. For anyone that's really interested in deepening the connection to math, you'll probably spend a lot of time in these green blocks, your operators, and these allow your robot to kind of perform different math operations and then have those operations trigger different events. So again, we can add, subtract, multiply, and divide. And then there's some other operators as well. We have greater than, equal to, and less than over here. And you can combine these as well to make more complex sort of algebraic expressions. So those are pretty neat and worth exploring. Then, of course, our last two sections are your variables and your my blocks. And these are ways of creating your own customized blocks in this sense, and variables would be different instances that reflect change. Like a variable is whenever something is going to change in your program. So those are a little more advanced, but certainly they're available for you. And if you've used them within Scratch, you're probably already familiar. And in another video, we're going to look at how to connect our robot, so we don't have to get into that too much detail on that right now. Down here, it's worth noting we have ways of zooming out, because sometimes you might have a whole a slew of different coding blocks in a single program. But then, of course, sometimes you also want to really zoom in so it's easier to read, particularly if you're displaying code in front of your class and you want them to be able to work with that code. This will center. It didn't do that. Let me try that again. Let me see if it's off screen, if that helps. Oh, it doesn't seem to work, so we're going to leave that one for now. Okay, and that concludes our tour of the EV3 classroom.